The polynomial p of x is given by this. Use the remainder theorem to find the remainder when p of x is divided by x plus 1. Use the factor theorem to show that x minus 3 is a factor of p of x. Express p of x as a product of linear factors. Sketch the curve with this equation, stating the values of x where the curve meets the x-axis. Okay, so let's have a look at this then. So, use the remainder theorem to find the remainder when it's divided by x minus 1. So part A then. Here we've got p of minus 1 is equal to, put it in here for the polynomial, minus 1 cubed, isn't it? Minus 4 times the minus 1 squared, minus 3 times the minus 1 plus the 18. Minus 1 cubed, minus times a minus is a minus. 3 minuses is a minus. This is a plus, times a minus is a minus. 4 ones are 4. Minus times minus is a plus. 3 ones are 3. Plus the 18. So we've got minus 5 plus 3 is minus 2. 18 take 2 is 16. So that's that. Use the factor theorem to show that x minus 3 is a factor then. So this is B part 1, and P of 3, let's see, we get 0, put 3 in, 3 cubed, minus 4 times 3 squared, minus 3 times 3, plus 18, 27, minus 4 nines are 36, minus 9, plus 18, 27 minus 36 is minus 9, minus another 9 is minus 18, plus 18 is 0. So x minus 3 then is a factor. Express p of x as a product of linear factors. So we've got here's our p of x, isn't it? Our cubic. We know that x minus 3 is a factor. So let's have a go at part 2 then. So here we've got this cubic then, x cubed minus 4x squared minus 3x plus 18 is equal to, and we know that the x minus 3 is a factor. So the other thing it must be a quadratic, ax squared plus bx plus c. So now we can find out the values of a, b and c. So let's equate the x cubed on both sides now then. So 1 here is equal to, and the x cubed, the only x cubed term is from this expansion here, ax cubed. So that tells us that a equals 1. Now we'll look at the constants, because that will give us c. On this side we've got 18. And when we expand these brackets, the only constant will be the minus 3c. So c must equal minus 6, mustn't it? So there's that one. And now I think next we could look, to get the b, let's look at the x squared terms. For minus 4 lots on this side. And the x squared terms on the other arise from x times this term. So there's b lots there. Minus 3a. So that tells us that b is equal to minus 4 plus the 3a, and a is 1. Minus 4 plus 3 is minus 1. In other words, b equals minus 1. Okay, there we go. So we've got a, b and c. So we've got this then, we've got x squared minus 6x minus 1 is equal to, now can we factorize this? 3 2's? No, it would be 1 times 1, wouldn't it, here? So this here, it looks like we can't factorize it. Let's have a look at b squared. 36 is b squared minus 4 times a times c. 1 times 1 is plus 4, is 40. So we're going to get some roots, aren't we? So we'll need to factorize, we'll need to find the roots. Just looked at this again, and I've written this round the wrong way, because A is 1, C is -6, and B is -1. So I think looking at that, simple mistake, but let's just correct it. So B is -1, and this will factorize easy now, won't it? And C is -6. So if that equals 0, then we can see we can factorize, can't we? 2 3's, isn't it? 3 and a 2. This is minus, so the bigger one needs to be minus. So we get x squared. Minus 3 plus 2 is minus 1 lot of x. Plus times minus is minus. 2 3's are 6. So x squared is equal to that then. Consequently, p of x is equal to, well, it would be x minus 3 here, and then x plus 2, and then another x minus 3, so it's equal to x minus 3 squared. So that's that factorized. So that was part 2. Sketch the curve with this equation, stating the values of x where it meets the axes. So let's have a look at that then. So now the sketch. Okay. So what part was that then? That was B part 1 and B part 2. C, the sketches. So this is C now. So we'll draw a couple of lines here. Like so. X, Y, 0. 3, when x is 3, is a root, and minus 2. It's a cubic, and the highest term is x cubed, so it must shoot up, come down, must turn somewhere here at 0. It must go back up, and then at minus 2. But it goes down. Ah, I see, it's a point of inflection here, it's got to be, isn't it? Yeah? So it's going to come down, turn here, but the only thing, 9 2's are 18, so it's going to shoot back up, quite steep, turn, but that would be a turn, yeah, turn, come back down, turn there, and then turn again and go back down. It's a very unusual cubic curve. I don't think it should do that route ordinarily. This is just a root at minus 2, isn't it? That's all. It's going to turn up here and just go back down. I don't know why I thought it would have a point of inflection. It's just going to go back down. Has to turn and then go back down. Like so. Yep. There we go. That's the curve then of P of x. And then it said, what did the question say? Stating the values of x where the curve meets the x-axis, which we've done.